And good afternoon, everybody. Here are going to be some more examples on simplifying trigonometric expressions. And a lot of these problems are going to have a focus on looking for situations where you can factor, so factoring, and trying to add or subtract fractions, so you might need common denominators. And here's our first example. So here's number 56 from the book. So when I look at this, the first thing I notice is we have sine to the fourth power and sine to the second power. So in the numerator, you have 4 factors of sine minus 2 factors of sine. So you could factor out a common factor of sine squared. So we'll go sine squared. So we will factor off that common factor, and what's left behind, you need another sine squared. So this would make you sine to the fourth if you were to multiply that back. So if you were to distribute the sine squared back in, you would get your sine to the fourth minus, and we took all of the sine squared out on this one, so you're going to have a 1 all over secant of x. And I'm now looking at what's left behind in parentheses. It looks like that has some of the parts and pieces of a Pythagorean identity. So we know that sine squared plus cosine squared is 1. So if we brought the 1 over here with the sine, that's going to get us sine squared minus 1. And then we'll bring the cosine squared to the other side. So negative cosine squared. So this is telling us that sine squared minus 1 is identical to a negative cosine squared. So we can replace that in the original expression. So sine squared. The parentheses, that's going to change to a negative cosine squared all over secant of x. And sine squared times cosine squared, we could move that to the front since that's just all multiplication. So we could move that to the front of the expression. So that's going to get us a negative sine squared, cosine squared. And the secant down bottom, we know secant's a reciprocal with cosine, so that's going to be 1 over cosine. And if you're dividing by a fraction, you can multiply by the reciprocal. So dividing by 1 over cosine would be the same thing as multiplying by cosine over 1. So the cosine is actually going to get multiplied against the other cosine squared. So when you multiply by the reciprocal, you're going to get negative sine squared. And then you have a cosine squared up top, and then we have another times cosine, so it's going to be cosine cubed. And that will be our simplified form. On this next problem, notice we have a factor of cosine on the first term and 3 factors of cosine, cosine times cosine times cosine on the second term. So you can factor off a common factor of cosine. And you're going to be left with a sine squared plus cosine squared all over secant. And this is one of our Pythagorean identities. Sine squared plus cosine squared is always 1. So all this will just turn to a value of 1. And 1 times cosine is just going to leave you with cosine up top all over secant down bottom. And secant is identical to 1 over cosine. And if you multiply by the reciprocal, we have cosine up top, cosine over 1, multiplied by the reciprocal of the bottom, which is cosine over 1. And cosine times cosine up top is going to get you cosine squared all over 1, so cosine squared. And here's number 60. This one we have a negative angle in the numerator, but you have positive angles in the denominator. All your angles need to match before you can begin doing any work with the trig identities. So we need to get matching angles. So if you have sine of a negative theta, and this is all being cubed, sine of a negative theta, we know sine is an odd trig function, so the negative can be brought out to the front. So you're going to have a negative sine of theta, and again this is all being cubed. So a negative sine times a negative sine times a negative sine, it's going to remain negative. If this happened to be an even power, like power of 4, then it would actually become positive, because a negative times a negative times a negative times a negative would make everything positive. But since it's an odd power, it's going to stay negative, and that's going to be sine of theta cubed. So up top we can replace that with a negative sine of theta cubed. And now all our angles are the same. We have a positive theta up top, and then we have sine of theta cubed minus sine down bottom. And probably in the same step, we could notice that we have a common factor of sine. So we could factor a sine out. And sine squared minus 1 will be left behind. And sine squared minus 1, we saw that from one of the earlier examples, sine squared minus 1, if you think of your Pythagorean identity. Sine squared plus cosine squared equals 1. So if you bring the 1 to this side and the cosine to this side, sine squared minus 1 is going to be identical to negative cosine squared. So we can replace that with a negative cosine squared. So we got negative sine cubed up top. We have a sine of theta multiplied by sine squared minus 1 is going to get changed to negative cosine squared. And then we can start looking to simplify a little bit further. We have a factor of sine down bottom and 3 factors of sine up top. So one of these will cancel one of the 3 factors up top. So up top you're just going to be left with sine times sine. So that's going to be a negative sine squared. All over a negative cosine squared. And a negative divided by a negative is a positive, and we know that sine squared over cosine squared is tangent squared. So we learned that tangent is identical to sine over cosine. That was one of our identities. So sine squared over cosine squared is tangent squared. And so that's the simplification of number 60. It should be tangent squared. And here's the next one. So this one, notice they are trying to add 2 fractions, or they're trying to add this to a fraction. So we could think of this as a fraction. It's just something over 1. So to add 2 fractions, you're going to need a common denominator. So this one has a denominator of sine. So the other fraction will need a common denominator of sine. If we look at the first fraction, It already had a common denominator, or it already had a denominator of sine. So we didn't really do anything to the first fraction except multiply it by 1 down bottom, since it stayed with a sine of x. So we multiplied the bottom essentially by 1, so it stayed sine. So whatever you do to the bottom, you have to do to the top. So the top is going to stay cosine. The first term, we changed the denominator, so we essentially factored in a sine down bottom. So we had to multiply the bottom by sine of x times the 1 that was there to produce the sine of x. So whatever you do to the bottom, you need to do to the top. So the top will have to get multiplied by sine of x. So sine of x times the sine of x is going to get you sine squared. Now that you have common denominators, you can put your fractions together. So we're going to have a common denominator of sine of x. And we can add the numerators, so sine squared plus cosine squared. And you can probably start to see where this is going. Sine squared plus cosine squared is 1 from our Pythagorean identity. So we get 1 over sine of x, and the reciprocal with sine is cosecant, so 1 over sine would just be cosecant. So that would be your simplification for number 62. And here's number 64. Similar idea. We can try to get a common denominator between the two terms. Right now this is 1 over 1. So you're going to need to multiply a tangent into the bottom, tangent squared. And whatever you do to the bottom, do to the top. So that 1 is going to become tangent squared over tangent squared, which is still the same value as 1. The second fraction, we already had a tangent squared. So we didn't do anything to the denominator, so we don't need to do anything to the numerator. And then we can go ahead and put our two fractions together, so it's going to be tangent squared minus secant squared all over tangent squared. And tangent squared minus secant squared, that is one of our Pythagorean identities, so we know 1 plus tangent squared is equal to secant squared. They have tangent squared minus secant, so if you brought your secant squared to the left side and then brought your 1 to the right side, then if you rewrote this original Pythagorean identity, it's going to be tangent squared, so tangent of x squared minus secant of x squared equals negative 1. So the numerator right here is essentially just a value of negative 1. So we have negative 1, and we know that tangent is the reciprocal with cotangent, so negative 1 up top, tangent down bottom. Tangent squared, so that's going to be negative 1 over cotangent of x squared. And if you're dividing by a fraction, you can multiply by the reciprocal, so that's going to leave you with a negative 1 multiplied by cotangent squared. And that should be your simplified form for number 64. And number 66, the first thing I would do is look to factor this. So this is actually following a Difference of two perfect squares factoring pattern. So a squared minus b squared should factor out to be a plus b and a minus b. So for example, if you had x squared minus 4, that factors out to be x plus 2 and x minus 2. So similar pattern, we just have some trig statements here. So we have a fourth power, which means the square root of that fourth power should be a power of 2. So if we were to factor this, we're going to get cosecant of x squared plus cotangent of x squared multiplied by cosecant of x squared minus cotangent of x squared. So there's your a plus b, a minus b factored pattern. And then we can look to see if we have any Pythagorean identities that would help us to simplify this. So maybe if we look at this one, we know one of the identities, 1 plus cotangent squared, is equal to cosecant squared. That was one of the Pythagorean identities. We have cosecant squared minus cotangent, so if we brought this to the right, it would read 1 equals cosecant squared minus cotangent squared. So cosecant squared minus cotangent squared is just 1. So this statement right here would just be a value of 1. So 1 times what we already have is just going to leave us with that first set of parentheses. So we're going to have cosecant of x squared plus cotangent of x squared. And that would be a simplified form for number 66.